Hello guys, welcome back to the channel. And now we are gonna start a new lecture with the topic neural networks. As you can see, a neural network is a computational model inspired by the human's brain structure and functioning. It consists of layers of interconnected nodes or neurons that process input data to produce output. Neural networks are widely used for tasks like image classification, natural language processing, and regression analysis. Key components of neural networks are there are six key components. The first one is input layer, which we give input for the data set. The second is hidden layers, layers between the input and output layers where the computation happens. They use activation functions like ReLU, sigmoid, or 10 to introduce non-linearity. This hidden layer is hidden by the users and it is not shown to them. The third is output layer, which is actually shown to the user of its output, which produces the final output, often using activation functions suitable for the task. Fourth is weights and biases. Parameters adjusted during training to minimize the error. Fifth is loss function. Measures the error between predicted and actual values. The sixth one is optimizer. Updates the weights to minimize the loss. Example gradient descent and Adam. Now let's start the code for neural network. I have arrange it in a sequential manner for you to understand it easily. First, we are importing TensorFlow STF. Then we are importing all the functions like sequential, dense, flatten, MNIST, and to categorical. As you can see, TensorFlow is a framework for building and training neural networks. Sequential function is used a model type that allows stacking layers linearly. Dense, a fully connected layer in the network. Flatten converts input data into a one diagram. MNIST, a dataset of handwritten digits 0 to 9, and two categorical convert label into one hot encoded format. Next is the step 2 in this, which is loading and preprocessing the data. This is very important step to preprocess the data. Data is normalized to range from 0 to 1 for faster convergence, and labels are encoded to work with categorical output. In this code, we can see that we are loading the data set like xtrain, ytrain, xtest, ytest into load data. Now we are just initializing the values and we are converting the ytrain and ytest to categorical values. Now, step 3 is build the neural network. We have to build the neural network. To initialize the model, we use model equal to sequential. This is the syntax for it. Then we add layers to it, which is model dot add flatten input shape 2828. It makes our network shape 28 by 28. Then dense and activation is equal to ReLU value. Means it is a hidden layer with 128 neurons and ReLU. Next is model dot add dense 10 activation is equal to softmax. This function gives us the output layer with 10 neurons. Now, flatten layer converts 2D image into 1D vector and dense layer converts fully connected layers with specified activation functions. Step 4 is train the model. Model.fit xtrain, bytrain, epochs, batch size, and validation split equal to zero point 0.2. Step 5 is evaluate the model. We have to evaluate the model when we are constructing it so that if we are doing any unnecessary things or we have made a mistake. So this is done by Test loss, test accuracy is equal to model dot evaluate x test, y test, verbose is equal to 2. And then we print the test accuracy. Now, last but not the least step, which is make predictions. So for this we have a syntax predictions. We are taking a variable prediction to store the model dot predict x test. We are predicting the x test data in this, and then import the numpy library as mp and matplotlib library as plt to plot the images. Then the syntax for plotting image is plt.imshow xtest. We are plotting xtest in the plot, and we are giving it a gray color. And the title of the plot is a predicted label. And then by using plt.show, we show the plot. So for conclusion, this code demonstrates a simple neural network for digit classification using TensorFlow and Keras. You can enhance it by experimenting with additional layers, activation functions, or hyperparameter tuning. Thank you very much.